Okay, this is our last look at an example of applications of quadratic equations. And here we have a familiar example from one we did a little while ago, and it's the rates with the hot and cold taps. So I'll just read it out here. We've got hot and cold taps, and we know they can fill a tub in 8 minutes. That's both of them together. The hot tap fills the tub 2 minutes faster than the cold tap. How long for each tap to fill the tub? And that just means each one by itself. So before I start working on this one, I just want to show you something that's important, because we're going to set up some rates here. If you know, for example, let's say the hot tap needs 10 minutes, and I'm just grabbing that number out of the air, then how much of the tub would you fill in 1 minute? So in 1 minute, you would fill 1/10 of the tub, okay, in 1 minute. Okay, so that's the rate per minute. If it takes 10 minutes to fill the tub, then we'll fill 1/10 of it in 1 minute. Similarly, if it takes 12 minutes to fill the tub, then in 1 minute you will have filled 1/12 of the tub. Okay, so all the rest of it's the same. So similarly, if I don't know how long it takes, suppose we use this somewhere down the road and we say, well, it takes X minutes to totally fill the tub. Then in 1 minute, we will have filled 1/X of that tub. Okay, so that's really important to understand that, because we're now going to set it up in a table. So I'm just going to clear the screen here. And what we have is we have two taps, the cold and the hot. And I'm going to put some information in a bit of a table here. So first things first, we're told that the hot water is a little bit faster at filling the tub than the cold water. So I think to avoid negatives, I'm going to say that it takes X minutes for the hot water tap to fill the tub, and that means the cold water needs X plus 2 minutes to fill. Okay, so that's the time needed to fill the tub. Now that means in 1 minute, how much of the tub does each tap fill? Well, the cold tap would be 1/X plus 2. Okay, that's the portion or the fraction that the cold water tap has filled in 1 minute. Similarly, the hot water tap fills 1/X, that fraction of the tub. So now we're going to put the two taps together. So we're going to say, okay, this is how much the cold water tap has put into the tub, plus the amount of water in 1 minute that the hot water tap puts into the tub. And what does that equal? Well, recall that we were told together the two taps can fill that tub in 8 minutes. So these two rates, these two proportions must be 1/8 of that tub. Well, that's my equation, and now I can just go ahead. The hard part is done. The thinking part is done. Now I just got to be very careful when I go to solve it. So I'm going to multiply to get rid of the fractions. I'm going to multiply by 8, because I got an 8 down here, and X, and also by an X plus 2. Okay, so that's going to be what I multiply every term by. So the first term, the X plus 2's cancel, and I'm left with 1 times the 8X. So this first guy just turns into 8X. Then plus, now the X cancels with this X, and I still got the 8, and I still got the stuff in brackets, X plus 2. And then finally on the right side, only the 8's cancel, so I'm left with the X times the X plus 2. Okay. Now I'm going to expand out the brackets, and of course collect all my terms slowly together in an effort to solve. So X times X is X squared, and plus 2X. And I can see x squared on the right side, so I think I'm going to keep it on the right side. And what I'm going to do is I'm going to move all these other terms over to the right side. So I want to have a 0 here. So I've got 16x's that I'm subtracting from the 2x. So that'll be minus 14x. And then I'm minusing over that 16. So there it is. And it would be very nice if I could factor it, but sadly I cannot. So I'm going to clear the screen and I'm going to use my little buddy, the quadratic formula. So we're going to clear the screen here and we're going to set it up for the quadratic formula. So negative b. Now b turned out to be negative 14. So got that, plus or minus the square root of, now we got b squared, minus 4 times a, which is 1, and c, which is negative 16. And that's all over 2 times a. Okay, so there it is, all set up. And let's just continue on here. So we got positive 14 plus or minus square root of, and all over 2. And the number I got here, be careful, when you're putting this in your calculator, you're better off to just ignore this negative and just put in 14 squared. We know it's going to go positive, so why risk a mistake from the calculator? In fact, here's what I would put in. I would put in 14 squared, then I see a negative and a negative, so I'm just going to go plus 4 times 16. Well, I know that's 64. So here's all I actually put in the calculator. And I got 260 when I did that. And then I'm going to work these numbers out. So 14 plus the square root of 260. Get that number and divide by 2. So that turns out to give me 15.06. And then when I plugged in 14 minus the square root of 260, took that number and divided by 2, I got negative 1.06. Now, if you look back in your table, and what was this x? X here is how many minutes for the hot water. So this is the number of minutes for the hot water to fill the tub. I don't know that a negative number would work, certainly not in our dimension, so I'm throwing it out. So this is my answer for the hot water. So if you just turn on the hot water tap, it'll be 15.06 minutes to fill. And for the cold water, if you look back to your table, the cold water was x plus 2. So for the cold water, it would just be 17.06 minutes. And there we have it. We've answered the question. Working independently, that's how long each of the taps would do it. And that's where I am done looking at applications of quadratic equations.